Tolerance Manager's Parameter Manager. Purposes of the demonstration: introduce the Parameter Manager, tolerancing and adjustment of the dimension chains. Part 1. Introducing the dimension chains. Parameter Manager regroups the whole functional equations created thanks to Tolerance Manager's different input tools. It has normative technological tables and statistical laws to attribute to the various parameters of the project. It contains tools to manage conflicts on values and to tune your parameters in an optimal way. In our example, the project is composed of 3 functional conditions. The first chain, FT001, previously described in the video on the linear chains editor. Let's visualize its plot. The second chain, FT002, lock overrun in the position locked. A mean overrun is necessary to ensure the locking of the lock. Minus L02 casing plus 0.5 T01 casing minus 0.5 T01 latch plus L01 latch plus L02 lock. And last, the chain FT003, lock overrun in the position lock open. The lock must not stand out from the latch to allow the door opening. Minus L03 lock, minus L02 latch, minus 0.5 T01 latch, plus 0.5 T01 casing, plus L02 casing. Selecting a chain highlights the parameters it's composed of. Selecting a parameter highlights the functional conditions it is used in. Second part, tolerancing of the dimension chains. The tolerance of our parameters must be attributed according to the way they are manufactured. The referencing of the tolerance ranges in the technological tables will allow to associate a capability to the dimensions. For instance, in our example, the parameter T01 casing will be obtained by plastic molding following the norm NTF 58000. The tolerance of our dimension is then attributed according to the technological table we use. In Tolerance Manager, it's possible to attribute a capability to a class of tolerance. Technologies can be duplicated from one parameter to another. A multiple selection is available for the parameters having the same technology. Our whole set of parameters are now linked to the manufacturing technologies. Your whole setup is saved in a design file that ensures the coherence between your design and its justification. We now have our setup with the technology used for each one of the functional parameters. Third part, tuning of the functional conditions. The Parameters Manager groups together all the information regarding the functional conditions. On the functional parameters side, we find again the dimension's name, its nominal value, tolerance and sensitivity, 1, -1 or 0.5, its unit, and its effect and weight on the functional condition. On the functional condition side, we can see the criticity of the conditions, its name, computed nominal, statistical dispersion or worst case, its status, optimized or not, and a mini chart that represents the gap between the condition's dispersion and the functional limits given by the functional specifications. Let's visualize the graphical result for our 3 functional conditions. First, let's analyze the chart for FT003. In red, the functioning condition defined by the functional specifications. in blue the statistical dispersion of the condition, together with the statistical distribution corresponding to our condition. The associated rejected rate is computed and displayed in ppm. We can see in our example that there is a gap between the range of the functioning conditions and the computed range. We will then have to recenter our condition to come back in the limits defined by the functional specifications. We have to move the nominal of one of our parameters to recenter the condition. We remind you that in a capable tolerancing, that's the range of our tolerance ranges which determines the dimension nominal values. To do this, let's use TM's wizard for the nominal value computation that will help us to recenter our condition. The wizard indicates us a value of 15.12 for L03 lock for FT003 to be centered. The status of FT003 is now validated. Our condition is now within the boundaries defined in the functional specifications. So it's clearly by centering our functional conditions that we'll manage to attribute the widest possible tolerances on our parameters. Choosing wide tolerances will avoid overquality and the extra cost that comes with. Let's do the same for FT001 and FT002. Our three functional conditions are now compliant with the functional specification requests. Our functional parameters are now matching the manufacturing process. The parameter manager is the dashboard for your functional conditions and parameters. It allows you to take the manufacturing feasibility of your product as early as possible during its design.